All right, welcome everyone to another deep dive. Today we're going to be exploring something pretty fascinating. It all started with a research paper you sent me, and it got me thinking.
Yeah, this one is a real head scratcher. It's all about AI.
AI, always a hot topic.
Ah,
But this is about how AI can learn, right?
right. How they can learn really complex stuff just by watching videos online.
Oh, interesting. So like watching us play video games and figuring it out.
Exactly. Like, imagine all those gameplay videos on YouTube and Twitch. Can an AI just watch those and learn how to play?
Okay, I'm already hooked. So what's the paper called?
It's called Open World Skill Discovery from Unsegmented Demonstrations. Kind of a mouthful.
It sounds pretty academic.
It is. It's from March 2025 from some researchers at Peking University and UCLA.
All right, so serious research going on here.
Absolutely. And the problem they're tackling is not simple. It's like, how can an AI break down those long videos into individual skills? Because the videos aren't labeled.
Yeah, no one's saying, hey, this is the part where I'm mining for diamonds.
Right. So how does the AI know what's a skill and what's just random actions? That's the puzzle.
Okay, I can see why this caught your eye. So where do we even begin with this? Like, why is it so hard for AI to learn from these videos?
Well, think about it. If you watched a movie, let's say a cooking show, but it was just one long shot with no breaks.
Yeah, just a continuous stream of chopping, stirring, who knows why.
Exactly. Would you be able to learn the individual recipes just from that? Probably not. You need to know where one recipe ends and the next one begins.
Right. Like, is this chopping part of making a salad, or is it for the main course?
And that's basically what AI struggles with too. They need some way to segment those videos, to figure out the boundaries between skills.
Okay, so no easy feat then. But haven't people tried this before? Like, to segment these videos somehow?
They have. They've tried a few different things. One idea is just to cut the video into equal chunks, like every 5 seconds.
Well, wouldn't that be super random?
It would. You might end up with half a skill in one chunk and half in another. It's not very reliable.
Yeah, that wouldn't teach the AI much. What else have they tried?
Another approach is to look for when the AI gets a reward. Like in a game, if you score a point or achieve a goal.
Oh, so the reward marks the end of a skill.
That's the idea. But it's not always so clear-cut. Some skills might involve multiple rewards, or the reward might come much later.
Like building a house in Minecraft takes a long time, with lots of little steps.
Exactly. So using rewards alone doesn't always work well.
What about predefining the skills? Like telling the AI in advance what to look for?
That's another option, but it's very limited. What if the AI sees a completely new skill it's never encountered before?
It wouldn't even know what to do with it, like trying to fit a square peg in a round hole.
Right. And there are methods that try to analyze the actions themselves, looking for patterns.
So if it sees the same sequence of actions repeated, that might be a skill?
Yeah, something like that. But these methods often get overwhelmed by the sheer amount of information, especially in open world games where there's so much going on visually.
Yeah, all those tiny details probably matter for understanding what's happening.
Exactly. And some games are partially observable, meaning the AI can't see everything at once.
Oh, like if it's controlling a character with a limited field of view.
Yeah, so those methods can struggle there too. They need more context to understand what's going on.
All right, so it seems like segmenting these videos is the key challenge here. But even if you could do that, how do you then teach the AI to actually perform those skills?
That's the second big hurdle. It's one thing to recognize a skill, it's another to actually be able to do it yourself.
Right, like I can watch a pro gamer pull off amazing moves, but that doesn't mean I can suddenly do them too.
So we need a way to go from identifying skills to actually training the AI to execute them. And that's where this new approach comes in, the one they describe in this paper.
Okay, the skill boundary detection thing, right? What's so special about it?
It's pretty clever, actually. It's a self-supervised method, meaning the AI learns on its own without needing labeled data.
That's already a big plus. So less work for us humans, more work for the machines.
And the inspiration for this method comes from, believe it or not, how humans learn. Specifically, how we break down our experiences into separate events.
Interesting. You're going to have to explain that one.
So there's this theory in cognitive science called event segmentation theory. Basically, it says that we humans naturally segment our continuous experiences into distinct events.
Like how we remember our day as a series of episodes rather than one long blur.
Yeah, exactly. And the key is that we tend to mark a boundary between events when something unexpected happens, when our predictions about what's going to happen next are violated.
Oh, so like if I'm walking down the street and suddenly a dog runs out barking, That's a new event.
Right. It disrupts the flow of what we were expecting. And this is what SBD tries to do with AI.
So the AI is constantly predicting what's going to happen next in the video.
Yes. They use a pre-trained AI model, one that's already learned a lot about how the world works, and this model makes predictions about the upcoming actions.
Okay, so like if the AI sees someone walking towards a tree, it might predict they're going to chop it down.
And if they do chop it down, the prediction is correct. But if they suddenly start dancing instead, that's a surprise.
A violation of expectations. That's when the AI marks a skill boundary.
Exactly. That sudden spike in prediction error suggests that something new is happening. A new skill is likely being performed.
That's pretty cool. So the AI is learning from its mistakes, from when it gets things wrong.
In a way, yes. And this is why it's annotation free. Because it's relying on this internal prediction error, it doesn't need humans to label the videos with skill boundaries.
So it can learn from any video, even the millions of unlabeled ones online.
That's the potential here. It could unlock a huge amount of data for AI training.
And the paper mentioned using an unconditional action prediction model at the start. What's unconditional about it?
Unconditional in this context means the model is trained to predict the next action based only on what it has seen in the video so far. It doesn't have any extra information about the player's goals or intentions.
Okay, so it's just learning the basic flow of actions, like what typically happens after what.
Yeah, it's building up a general understanding of how things work in the environment.
And then later on, it can use that knowledge to detect when something unusual happens, when a new skill is being performed.
Right. It's like learning the rules of the game before trying to figure out the strategies.
All right, so this SBD approach is all about identifying these skill boundaries. But the paper also talks about some assumptions that this method relies on. Like, what are the underlying beliefs about how skills work?
There are three main assumptions, and they kind of make intuitive sense when you think about it. The first is skill consistency.
Okay, what does that mean?
Basically, it means that skills don't change every other second. When someone's performing a skill, they usually stick with it for a while.
Like, you wouldn't be mining for ore one moment and building a house the next, then fighting a monster, all in rapid succession.
Right. There's usually some coherence to our actions. And they introduce this parameter K, which represents how infrequent skill changes are. It's assumed to be a large number.
Okay, so K is like the stick-to-itiveness factor. What's the second assumption?
It's called skill confidence. And it basically assumes that when someone's doing a skill, they're generally confident in their actions.
Makes sense. You're not going to be fumbling around if you know what you're doing.
They mention C as the minimum level of confidence and delta as a small value representing how often the agent might perform a less confident action.
So most actions within a skill are done with a certain level of assurance.
Right, which helps make the predictions more reliable when a skill is being performed consistently.
And what about the third assumption?
The third one is really important. It's called action deviance at skill transition.
Okay, that sounds complex. Break it down for me.
It basically says that when someone switches to a new skill, the first action of that new skill is likely to be quite different from what they were doing before.
So it's like a break in the pattern, a sudden change in behavior.
Exactly. And they use M to represent this difference. Think of it like if you're walking and then suddenly you jump.
That jump would be a very different action from just walking, and it might signal a new skill.
Yeah, it would be less predictable based on the previous actions, and this is what the AI is looking for, those moments of surprise.
Oh, I see. So those surprising actions, those deviations from the expected pattern, are what trigger the skill boundary detection.
That's the gist of it. And they even have a theorem, Theorem 3.4, which shows mathematically that the prediction error will be higher at those skill transition points.
Okay, so there's some serious math backing up this idea.
It provides the theoretical justification for why using prediction error works for identifying skills.
So it's not just intuition, it's grounded in solid theory. Now let's get to the good stuff. How did they actually test this SBD method? What did they do?
They chose Minecraft as their testing ground.
Minecraft, the block building game.
Yep, that's the one. It's a great environment for this kind of research because it's open world, it has tons of complex skills, and there are tons of gameplay videos online.
So it's a perfect real-world scenario to test this idea.
Exactly. And they went through a 4-stage process. First, they pre-trained their models.
What kind of models?
They use some existing models that are already really good at understanding visual information and actions, models like VPT3X and Transformer XL. They've already learned a lot from watching tons of videos, including YouTube videos.
So they're not starting from scratch. They're leveraging what's already out there.
Yeah, smart move. And for the YouTube videos, they even used an inverse dynamics model to figure out the actions from the video.
Inverse dynamics model. Sounds complicated.
It basically means they could infer what actions the player was doing just by seeing how the game world changed.
Oh, that's cool. So they didn't need labeled actions. They could figure it out from the visual cues.
Exactly. And then comes the second stage, the actual skill boundary detection.
So how does that work in practice?
They take those long Minecraft videos and feed them to the pre-trained model. The model makes predictions, and they calculate the prediction error.
And when that error goes above a certain threshold, they mark a skill boundary.
Right. They have this parameter called GAP, and they set it to 18 in their experiments.
So when the prediction error jumps above 18, that's a sign of a new skill.
Yeah, that's the basic idea. And they also explored adding some extra information to help the process.
Like what?
They used the in-game event logs. So in Minecraft, when you do something, it gets logged.
Like mined a block of iron or used a crafting table.
Exactly. And this information can be really helpful for detecting skill transitions that might not be visually obvious.
Oh, I see. So some skills might not have big visual changes, but the event log reveals what's happening.
Like, crafting an item might not look very exciting on screen, but the event log clearly shows that a crafting event occurred.
So they combine the prediction error with this extra information to make the segmentation even more accurate.
Yes. They found that using both together was generally the best approach.
Okay, so now they have these nicely segmented videos, hopefully each containing a single skill. What do they do with them?
That's stage 3, atomic skill acquisition. They use these segments to train AI policies to actually perform those skills.
So they're teaching the AI to do what it sees in the video.
Right. They use two types of policies, video conditioned and language conditioned.
What's the difference?
Video conditioned policies learn by watching video demonstrations. They used a model called Jurut for this.
So Juro learns by mimicking what it sees in the video.
Yeah, pretty much. And language conditioned policies learn from textual instructions. They use a model called Steve 1 for this.
So Steve 1 is more like, okay, go mine 3 blocks of coal and bring them back.
Exactly. It understands and follows instructions.
And the fourth and final stage.
Stage 4 is long horizon task execution. This is where they put it all together.
So now they're going beyond just individual skills.
Yes. They build hierarchical agents that can combine multiple skills to achieve more complex goals.
Like not just chopping down a tree, but building a whole house.
Right. And they use advanced models that can understand both visual information and language to guide this process.
So it's like a team of AIs working together, one figuring out the plan, the others executing the individual skills.
That's a good way to think about it. They used approaches like in-context learning with a system called Jarvis 1 and imitation learning with OmniJarvis.
Okay, so they threw a lot of fancy AI at this problem. What were the results? Did it actually work?
It did. They saw some really significant improvements. For those atomic skills, the ones they trained with Groot and Steve 1, they saw performance boosts of over 60% compared to using other methods.
Wow, that's a huge jump. So this SBD method is really effective for teaching those individual skills.
It seems so. And for the more complex tasks, the ones with multiple skills, they also saw improvements. OmniJarvis got 11% better, and Jarvis 1, get this, 20% better.
Okay, so it's not just a theoretical win. It actually translates to better performance in practice.
Exactly. And they did this ablation study where they removed parts of the method to see how important each part was.
Like a scientific what-if experiment.
Right. And they found that using both the prediction error and the extra in-game information together was generally the best, although there were a few cases where it was actually better to use just one or the other.
So it's not a one-size-fits-all solution, but overall, the combination works best.
Yeah. And they looked at some visualizations of the data, which provided more insights.
What did the visualizations show?
One interesting finding was that the lengths of the segments created by using just the prediction error were similar to the lengths of segments defined by the in-game events.
So the AI is, in a way, learning to segment the videos in a way that aligns with how the game itself defines events.
That's what it suggests. And that's pretty remarkable because it means the AI is picking up on meaningful chunks of action without being explicitly told what those chunks are.
And they also showed some examples of the segmented skills, right?
They did, like a
Yes.
short clip of the player sleeping in a bed or another of them collecting grass. It just makes it more concrete, you know?
Yeah, it brings it to life.
Hmm.
Okay, so this SBD method seems pretty groundbreaking. How does it compare to other research in this area?
Well, there have been other attempts to learn from unsegmented videos, but they often rely on some kind of weak supervision, or they struggle with the visual complexity of open world
So
environments.
they either need some help from humans or they can't handle all the visual details.
Right. SPD seems to overcome these limitations, and they also connect it back to event segmentation theory, which is a strong theoretical foundation.
Oh, so it's not just a random idea. It's rooted in how humans actually learn.
That's the beauty of it. And they mention this whole community of researchers working on AI in Minecraft.
So it's a hot topic. Lots of people are interested in this.
Absolutely. But they do acknowledge that there are still some limitations to this SBD method.
Like,
One is computational cost. It takes a lot of computing power and time to process these videos.
so it's not super efficient yet.
Not yet.
Yeah.
And it can also be unstable in situations with very rapid action changes.
Like a fast-paced fight scene.
Yeah, that kind of thing. But they have ideas for future work, like improving efficiency, exploring other games, and refining the parameters.
So there's still room for improvement, but it's a very promising start.
Definitely. I think the key takeaway here is that this SBD method offers a really new way to think about how AI can learn from the massive amount of unlabeled video data out there.
But taking inspiration from human cognition, they've created an AI that can learn by watching and noticing when its expectations are violated.
And the potential applications are huge, from automating tasks to personalized learning to even understanding intelligence itself.
It's mind-blowing to think about AI learning complex skills just by observing. It makes you wonder what other fields could benefit from this.
Absolutely. And the paper didn't even mention this, but imagine applying this to things like sports analysis. Could an AI learn to identify the key moments in a game, the subtle skills that separate the pros from the amateurs?
Or in medical training, could it help doctors learn new surgical techniques just by watching videos of expert surgeons? The possibilities are endless.
It's a fascinating area of research, and this SBD method seems like a big step forward. It's going to be really interesting to see what comes next.
Absolutely. Well, that was a deep dive indeed. Thanks for bringing this paper to my attention. It's given me a lot to think about. And I'm sure our listeners will be pondering the implications of this as well. Until next time, keep exploring and keep learning.